I'm very proud to be here today and talk to you about the Fraunhofer model. Actually, I see many familiar faces here. Some I have worked with, some I have met in other capacities. The purpose of my presentation today is to familiarize yourself with the Fraunhofer model. And as an introduction statement, probably, in Germany we have two large research organizations that are between university and practice. One is called Max Planck, which you probably know. There is one subsidiary here in the building, and Fraunhofer. Max Planck's mission is basic research, and as a result, they are 100% base funded. Fraunhofer's mission is applied research and technology transfer, and I will come back to the funding model, so we are only getting a fraction of base funding, and the rest is done by means of projects with industry in Germany, Europe, and beyond. Lionel already said that I'm at the university in Fraunhofer, and that's an important thing. Those of you who got my business card will see that I always carry university and Fraunhofer. And that's one of the success principles actually of Fraunhofer, that it was decided early on that Fraunhofer directors have to have a chair at university to ensure the collaboration between basic research and applied research. Otherwise, there would have been a danger that we split and drift apart. I will tell you a few of the other success criteria later. So what I would like to do today is tell you mostly about the Fraunhofer Gesellschaft, the organization, which was started in 1949 after the Second World War in order to help German, especially small and mid-sized company, to get on their feet. The one institute I'm directing, which is the Fraunhofer Institute for Experimental Software Engineering, and experimental actually stands for the scientific approach that we believe, like in other engineering disciplines. You can't just sell new methods and tools. You have to be able to make statements about their strengths, their weaknesses. So you need kind of empirical evidence to say under what circumstances, what kind of companies, for what purpose should you use it. And that's what's standing behind this term experimental. And I would like to show you how in the city of Kaiserslautern, which if you look at the vicinity is probably a vicinity of about 250,000 people, we have used the Fraunhofer Institutes, by now we have 3 in Kaiserslautern, to actually drive the economic development. We have lost lots of companies in the production world and have created basically a different economy, and what the role of Fraunhofer was in this game. So let me start with the overview of Fraunhofer. Here, just a few numbers. Fraunhofer has long been expanded from a German to a European research organization, and it's, according to lots of measures, the largest and probably also most successful applied research organization in Europe. We have currently about 67 institutes and research units in Germany and Europe, more than 23,000 people, and the budget is roughly 2 billion annually. And this is the second success principle after joint membership of university and Fraunhofer, that 2/3 of the income has to be generated externally. So Fraunhofer has decided from the outset, we don't leave it up to the people to self-judge whether they do good applied research. I know many colleagues who claim to do applied research and say industry is just too dumb to recognize it. So we wanted to get out of the subjective judgment, and there is a judgment: if you cannot sell it to industry, not right away, but after some period of time, then it's not good applied research. Then it's useless. And so there is a self-induced kind of feedback loop, which is one of the major governance principles, that you have to have this 2/3 outside income. Now, you all can do arithmetic. Base funding 1/3. That's within the Fraunhofer model. Of course, it's more than 1/3, because the chairs of the directors at universities, we have about 40 employees, scientists at university. They do not count officially in Fraunhofer, but of course, we don't do completely separate things at university as we do at Fraunhofer. So in fact, I would claim the base funding is between around 40 to 45% of Fraunhofer, but not within the Fraunhofer rule. So I can never say this in an official Fraunhofer talk, but I can say it here. And of course, we look for international collaboration everywhere. Actually, Europe to us is the same as Germany. So from a government point of view, whether we start a center in Germany, in France, or in Italy, or in Luxembourg, doesn't really matter. It matters if we go to Brazil or to let's say, Australia or someplace outside the European Union. The mission statement of Fraunhofer is pretty clear. We want to conduct applied research in the national context, and the measure is to benefit private-public enterprise and to, as a result, make this an asset of society as a whole. Now, in Germany, actually, states and federal government is interested in Fraunhofer institutes, because if you think about it, it's one of the cheapest investments into research, 1/3, but with the biggest impact, which I will demonstrate to you later. Fraunhofer institutes help to reinforce the competitive strengths of cities, regions, countries, depending how you are positioned in Europe. And as an employer, we develop staff to become competitive, so we develop their professional, personal skills. So in Germany, when you pick a company, it's above 50% chance that the top technical people, CTOs and so on, have spent 5 to 10 years at Fraunhofer. So it's a normal career path into industry, because you learn not only science and engineering, you learn all the soft skills, project management, whatever is involved in running successful projects later in industry. I just lost, I have to say, one of my chief architects to become chief architect at a company like John Deere. Now, on the one hand, I was sorry. This was done in agreement, of course. Yeah? On the other hand, now that increases our network, so we will have more contracts from John Deere. So that's part of the game, creating a network. The name of Fraunhofer comes from a German-speaking scientist, Josef von Fraunhofer. As you can see from time he lived, he didn't know our organization, but he was supposedly the first German scientist who made money out of science. And so in some sense, that's the motto for a Fraunhofer scientist. I mean, you probably know him. If you are in optics, you know the Fraunhofer spectral line, which is named after him. He developed a new method for lens processing, and he developed a first factory to build these kinds of devices. So if you go into Dresden or so, you will see all these exhibits, what he produced. And that's the idea. Doesn't mean everybody has to do it, but that's the mental state of a Fraunhofer employee, to do good basic research, but always think about a problem you would like to contribute. By the way, if there is any questions or so, please don't hesitate to interrupt me. My purpose is more to get things across to you, and so if I should be too short or too long, you can also yawn, then I will speed up. Please ask. So, what the contribution of Fraunhofer was in the past, Josef von Fraunhofer, is still what we do today. So we do develop research and development on behalf of industry and state, of government. We develop patents in many regards. The most well-known is the MP3 patent, which actually gave us 2 billion of revenues, of license revenues. So today, many of our internal research programs are the result of this income. We are now looking for the next 2 billion license income, but we also learned you can't blend this so easily. This is something we have developed a patent on a safety certification technique, which is now used in automotive industry. This is one contribution, doesn't give us quite the same income, but it's still important, and this is our actual income annually. And one aspect is, of course, also that we create spin-offs. In a very nutshell, the organization, we have 67 institutes, so my institute is one of these. They are organized into 7 groups according to core competences, and you probably can see that production materials and so on are the traditional ones in the engineering community, like microelectronics, life sciences, information technology. Where we belong to is more the younger ones when you look at the entire lifetime. We of course have an executive board, we have scientific advisors from industry, and each institute itself has an advisory board that drives the strategy of each institute. The institutes are spread, the German ones, all over Germany. We are here, not too far from Luxembourg. So I drove about 1 hour, 40 minutes just to give you a sense of the distance. Most of the new founded institutes in the past 20 years were in the eastern part for obvious reasons. They didn't have Fraunhofer institutes until a few decades ago. So again, this is kind of the line structure. Each institute is in one of these clusters. We are in ICT, but then we have cross-cutting clusters, which are called alliances, which are aligned to solve problems. And the strength of Fraunhofer is actually that we have all technical areas represented. So when we work in software IT with a company, they have a materials problem in car, we bring in an institute from that part. Energy management or batteries, we bring in an institute. So the capacity of Fraunhofer to solve problems and not only say, that's what we can do, take it or leave it, is a big asset of this organization. So I have just mentioned a few things where we are involved. Ambient assisted living is an approach to use technology in a hidden way, ambient way, to allow elderly people to live longer at home. Here we have big field studies already with our technology. Cloud computing, e-government, we are actually advisor to federal, state and municipal governments in Germany. Actually, that we have these 3 levels. We very often envy Luxembourg, because to make a change in e-government or in government at all, sometimes we would like to be smaller and not have the 3-level structure in Germany. This is crazy, but that's a separate talk. Embedded systems and energy, of course, always we are involved here from an ICT energy management point of view. So we are not claiming to do energy, that's done then by institutes from other areas. And these alliances actually change every 5 to 10 years, because there is different challenges. The line structure, the main core competence areas, they remain the same. Internationally, as I mentioned already, Fraunhofer has started about 8 to 10 years ago to create centers all over Europe. You see just a few of them. They are in different status, whether it's a subsidiary, own center, etc. There is different states of establishing a new entity, but we also have, for historical reasons, 7 centers in the United States. By the way, let me take this, because the latest one we created at MIT. And so I want to use this as a case to say something like Fraunhofer. I'm not saying exactly what we are doing, but something like Fraunhofer, this bridge, is needed everywhere. Even in the United States, and I know this environment well because I was there for 10 years, they are very good creating impact. But impact is created by spin-offs and by producing good people, but not by strategic collaborations with companies. Why? Because in a university you don't have the people who can do this, the critical mass of people. After a PhD you are typically leaving. So MIT decided they needed for certain areas something like Fraunhofer to actually establish that strategic collaboration with large companies. Now, in every country, Fraunhofer is built different. View a bridge. A bridge is a bridge, but it's different whether you build a bridge over this river or this river. For instance, when I think of Japan, where we are present, the distance between university and industry is huge. In the States, it's smaller. So when you build a Fraunhofer entity, you have to very carefully analyze the situation. Where is the basic research community positioned? Where is industry positioned? And then adjust, if you want to add something, adjust it to bridge that gap. In the United States, they call it Death Valley, the Death Valley of innovation between basic research and industry. Now, my institute itself, we have a center in the United States, in Brazil, and in Australia for very different reasons, which I don't have time to explain here. Just here a list, you can have these slides later. You might be able to see some of the European-based subsidiaries we do have. A little bit about size, and I do this fast if someone is interested. You can see here the development of Fraunhofer over the past 4 to 5 years. So right now, we have an overall business volume of a little bit more than 2 billion. The large majority is contract research. By the way, contract research here means money achieved in a competitive way. Half of this about is directly with industry, and half of it is through European projects, national projects, but we cannot participate in a European or national project without bringing in industry for us. Because the idea of our philosophy is we do applied research in a European project, but we bring our potential future customers already into the game, even if they don't get money. The contract research is, in some sense, or not the contract, the other research is basically direct industrial revenues, and this is in Germany from federal and state, and this is from Europe. We don't have that many European projects because, as opposed to base-funded organizations, we can only afford so many projects which are not completely funded. We have to very wisely decide what we use our 1/3 base funding for. Yeah, so you will find organizations that have more European projects, because if you have 100% base funding, you can basically use a large amount to match. This is one of the problems if you want to have European projects we do have. Now this is the non-German income at this point in time. Probably not a surprise that United States is leading here, because we have 7 centers. And probably going back to Europe, you will find here not only big countries, but also small countries. And Luxembourg is not yet on this top 10 list. The active research areas we are currently driving are these 6. And these are not research areas of one institute, but of alliances across all competences. This is one actually energy, in terms of energy management, which I'm currently driving, and safety security is one that my co-institute director, Peter Liggesmeier, is driving within Fraunhofer. People, I mean, as you can see here, we have a large majority of full-time staff, mostly scientists, engineers, because to do a strategic project with industry, you can't just depend on students. Yeah? You never know how long they are there. We have a rule of thumb that if we declare something to be a competence, we have to have at least 10 active researchers on that topic. Because I can never promise a company, we accompany developing your next generation product. We work with Audi on the next e-car generation. I couldn't do this with my PhD students because I can't promise whether once they graduate, whether I get a replacement who is doing the same thing. So that's the advantage of Fraunhofer, that we have not only professional people, we have already a critical mass. And in Fraunhofer institutes, we also have some kind of security measures, because we are working with competing companies, which I could not do at the university. The strength of a university is openness. Yeah? And so I mean, it's harder to do these kinds of projects that are close already to the heart of a company. And so the rest is graduate students, typically master and PhD students. Now the next slide gives you a little bit types of contracts we do have. And this is actually across the entire organization. We do individual projects. Where a company has a problem, is calling us because they had a recall action, we are supposed to help them. Yeah? We have large-scale projects with multiple partners. For instance, we have projects with all commercial vehicle companies to do kind of improved diagnostics. They all have the same problem. So we put together consortia of companies and include multiple Fraunhofer institutes to cover the individual domains. We have, of course, international collaboration. We typically organize across Fraunhofer offices abroad. We have strategic partnerships. Strategic is a collaboration where we basically say we develop the next generation of product or process. That's really something that's at the core of a company. And for that especially, we need to have long-term partnerships, and we have to have competences that are covered by a large number of people. As I told you already, gave you an example, sometimes in these strategic collaborations especially, people are moving changing sites. So go from Fraunhofer to companies, sometimes even the other way around. Innovation clusters, that's something where we set up in regions. In Kaiserslautern, we have set up an innovation cluster for commercial vehicle technology. So the idea here is to tie together all the competences, and the KPI, the success criteria, is then to attract more companies, create more jobs in that, to build up an economy in that area. Spin-offs, we do a lot. This is probably less in IT than in some other areas, but also in IT we have lots of spin-offs. We discussed this before. The current situation in IT or computer science is not very good for creating spin-offs, because most of the talented guys have so good offers in industry or somewhere else that the temptation to start a company is not as high as it would be otherwise. Improving products. You see down here also improving processes, what we do typically. Improving products. For instance, you have a system where you want to enhance performance, make it more cost efficient. Moving product from product development to short-term production. That's of course more in the context of production technology institutes. That's not so much. This is the only area where we as an ICT or software institutes don't have collaboration. We are very often called to do market analysis. Here the independence of Fraunhofer counts. We do with large companies innovation development, bringing in our experience of working not only with one company in one sector but different sectors, and help them to develop roadmaps towards that. And incorporating new technologies into daily work. So these are, I would say, complementary things to the main types of projects types I had on the previous one. Now, to complete this, acquiring licenses, of course. So we do our own research. So if we want to have the sole IP, we can do it jointly with companies. Then we use our license income, the 2 million from MP3, and define projects where we create Fraunhofer IP. That's a separate thing. Existing processes, this is a lot also in software engineering, whether it's in banks or whether it's in other organizations. And characterization, testing, certification. By the way, we do not do certification, but we help companies to prepare for certification. Currently we are building a certification center for software in the medical world, for medical products in Brazil. They are building up an industry in that part, and so that's one of the competences we also bring in. But the main projects are on the first page I listed to you. So, this is the overall Fraunhofer organization. Actually, when I came back from the United States, I only knew the name Fraunhofer in 1992. I didn't really know Fraunhofer. But I knew from my work in the United States, being at university, doing basic research and education, and being able to apply things in practice, that this is the setup for doing work in an engineering domain. And to me, software engineering is engineering. It's not any different than any other engineering discipline. Yes, it's different in methods, it's different in terms of its laws, but it's still engineering, and you can teach it, and you can do good basic research from my point of view if you are not infected by what's going on in the world. And so when I came back from the US, I was looking for doing something similar. I started industry projects, and then suddenly the number of industry projects got too large. That's how I got into Fraunhofer. And I can still say, after more than 20 years now, the basic system of bridging this gap in a way without creating different worlds. So I repeat this, being at university and Fraunhofer is the key. And doing it in a way where you have actually, as a judgment, whether you are solving problems in practice. And by the way, this is not only short term. You would be surprised, some of our most basic research we do in some of the industry projects, but only after we have created trust and have strategic relationships. Yeah? You always get in solving a problem. That's what you have to use to create trust in industry, that you can do this, that you take it serious. And then you can get involved in more serious things. And I don't know any public projects where we have so long number of years to solve problems as in some of the industry projects. Now, this is just one of the institutes. Some of you have been here. This is our location in Kaiserslautern. And I think we are claiming we are one of the leading, not we are claiming, we're being told, one of the leading institutes in software systems engineering, I think, in Germany and beyond. We have currently about 230, 40 employees. And we apply our software engineering competence in 5 application or in fields. That's automotive or mobile, not mobile, automotive or mobility. That's health and medical devices. That's energy. That's finance sector. What did I miss now? Oh, in telecommunication, yeah, which is, of course, decreasing a little bit, yeah, given the number of firms that are around. And we have special departments for all phases of life cycle of software development. I use this structure to introduce the overall also content structure. Besides the board, we have here 3 divisions. The first division is focused on embedded software, construction and analysis. The same here for information systems or software systems, construction and analysis. Yeah? Now, the difference here, you see 3, is that we have learned over time that you can do embedded software development without understanding the systems. So we have now engineers on board, because the acceptance is just larger if you don't just solve problems at a level of abstraction, but if you can do system solutions. Especially one of the challenges in this world of embedded systems is system modeling. You know, every time I go to a company, I say, show me the system architecture. What they then do is show me the hardware. They show me the hardware architecture. I say, I don't want to see the hardware architecture. I want to see the system architecture. They don't. They can show me the software architecture and the hardware architecture, but not the system architecture. And I think one of the biggest benefits in simplifying systems lies at this level. And this is where software, computer science can actually contribute a lot. But we can only contribute it if we speak the language, if we know the challenges, if we know the standards in system engineering. That's the reason why this construction side here has been split in 2. And then in the middle we have something where I originally come from: measurement, prediction, empiricism, and process modeling, compliance, and improvement. This is, besides having a meaning for itself, is the vehicle to transfer innovations from these 2 worlds into practice. Because you can't throw it over the fence. You have to integrate it into process in the company. You have to develop models that allow prediction, control, and so on. So this is how you actually manifest it in an organization, whether it comes from here or here. Now, this is kind of a matrix structure, because we have also learned that, of course, we have software engineering competence, but we also need to understand the challenges, roadmaps, technologies in these application domains. So we have something what we call business area managers, who are experts in these domains and can actually talk to these companies. I mean, I always realized when you talk to top-level people and you come and speak in academic terms, the acceptance is limited, to say the least. Yeah? So we need these kinds of translators to actually gain that kind of acceptance at top levels at least. Now, this is a little bit the trend we see in software. Remember when I was young, it must be a long time ago, and started in this field, we had software was either embedded software or it was information systems. They were separate worlds, because in the embedded world, safety was dealt with independently. In the information system world, it was security, data security, user acceptance, etc. Now these systems are more and more merging. There is terms like systems of systems, like cyber-physical systems. What we say in the end, they are all merging. When you, for instance, look in a car today, when I started, there was 5 or 6 or 7 devices with a little bit of software on top, 50,000 lights. I mean, even without engineering, you could get that software to work by working 3 days and nights, or the weekends. Today, we have 30 million in a mid-class car. They are all interconnected. Yeah, the windshield wiper, recognizing waterfall, has an impact how you calibrate the brakes. So, if there is a miscommunication between the two, a security problem causes a safety problem. Yeah? And this kind of coming together poses significant challenges. For those of you who are in that field of safety security, you know that safety can be easily quantified. We do this for years. Now we have to quantify it despite the impact of security, which you know is not so easily quantified. So how do we do this in coming years? That's one challenge. And the other challenge is, and I also recognize this in Lionel's research map, that we cannot check everything during design time. Because not only because there might be defects left, but because systems change during runtime. We talk about intelligent systems with microsensors, which recognize context and adapt to that changing context. So you have to be able to do at least verification and validation during runtime. And this is not what software engineering did until, I would say, 5 years ago. So these are the two threads where our research is currently focusing to adapt our competences in, I call it, static, standalone systems to dynamic, integrated systems. And even worse, in these integrated open systems, you have sometimes system components you don't even know, yeah, because you take from somewhere else. So this openness, this dynamic adaptation has changed the challenges in our world, and this is what we see as a trend. So how do we position ourselves? In a nutshell, we provide scalable engineering. So scalable is here the important term. It's applicable also to large systems. So for instance, we take from the university fault-free technology. But when you apply this with a car manufacturer and suppliers, you can't apply it because the supply company will not open up its internals. So we had to modularize this to scale it for large systems. So this is kind of the applied research we very often do, that we take results which exist in basic research and for teaching, but very often they have limits when you do large systems. So scalable, guaranteed quality. We want to provide methods where you can guarantee certain results. Behind guaranteed is, of course, partly our empirical or experimental approach, and we want to apply this to all kinds of innovations that are software enabled. So not only in the software industry, in the banking industry, in the car industry, in the medical advice, everywhere where the major innovation comes from software. And you would probably have a hard time finding any domain where today most of the innovations do not involve software. Yeah? When you look at cars, everything the customer values in a certain brand versus another, security, safety, less fuel consumption, etc., would be impossible without software. So also these companies have to learn that if you want to be competitive, they do not only have to be the best in their traditional engineering competence, they also have to become the best in the related software competence. Otherwise, they will not be competitive. So if you take the next step, our core competences is we focus mostly on the entire process, so a lot of model-based development. The models are, of course, different depending which domain, depending which quality, but we mostly focus in terms of new technologies on the upfront activities, requirements, and architecture most of all. Architecture is the key for maintaining systems over releases or maintaining systems over variants. Yeah? By the way, banks, this is one of my hobbies. Fraunhofer is doing evaluations for Deutsche Bank before they invest into companies. And so what we do is, or not what we do, what German Bank does, they evaluate the business plan, evaluate the marketing plan. We convinced them they should also evaluate the software. Because in most of these businesses you have somewhere software at the core of this company. Why? Because in engineering we would never go into a company if the product is not mature, producible. In software we very often go with prototypes into companies. What is the result if you have a hacked software product? Now the more customers you get, the more you get underwater. Why? Because that prototype, to make the adaptations the customer wants, requires so much effort that you will never make money. So what we said is, when you evaluate the maturity of the product, in engineering that's much more established. Also evaluate the software part. Because if that's not mature, ready to be adapted, ready to be easily changed, then this company will never make money. And so this is now the deal we have with Deutsche Bank, that we basically evaluate proposals for investing capital into spin-offs or also second, third phases of company development. And so on the quality side, we focus on safety for embedded systems, and security, here we focus not so much on access control, but on data usage control. Because in more and more of these ecosystems, you are using very personalized data, whether it's energy management, whether it's health management, it doesn't matter. Intelligence always comes from data. And people want to be sure that data are not misused. That's the focus here. And user experience, which for those of you who don't know, in past we talked about usability. So you can use a system. User experience is a more comprehensive term. You actually want to use the system. This comes actually from the Apple world, where you said, I mean, there is a certain common and always equal user experience, independent what kind of system, what kind of product you are using. This is more and more important. Even, I mentioned this again, John Deere, a company building tractors, they move right now from building tractors to providing solutions for managing a farm. And in these kind of app stores where they support these activities, they also want to have a John Deere user experience. So not just hack it in some way, but produce it in a way that reflects John Deere corporate identity to the user. And then we do it from the information system side. Remember, this was the third division, where the term mobility is, of course, our mobile devices taking on a more and more important term. Embedded systems, where you have so-called cyber-physical systems, systems of systems, but we really believe that this is the trend which we see already in many domains, that both of these types of systems are integrated. So you cannot do any service anymore by looking at one part. You have to be able to mix and merge these two worlds. For those of you who are a little bit more into technical detail, this is again the three divisions. And so the concentration here on the embedded side is architecture, not only of software, but of systems. So we build architecture of system. For instance, we are doing the requirements architecture and certification for a new German frigate of the German Navy. Yeah? So, of course, our focus is technically on software, but we cannot start before looking at the entire system. And this, you can probably imagine that this requires scalability. Yeah? You can't use technologies that apply to 500-line programs. Variation management, it becomes more and more standard that in engineering we talk about product lines, that also in software we talk about product lines. So we have, for instance, helped companies who build systems for stock market management of private groups or people to produce new customized versions for a customer from 2 weeks to half a day, which actually gave them lots of benefits. The key is you look at the variation, say what do they have in common, what is changes that you can control, and what might be the last remaining percentages that are unique for each application. So a product line means you build on common artifacts, not only code, but also code, and allow by that not only to faster build variations, but also require much less in verification and validation. Because of course reuse is the key to reduce that cost. Safety engineering, I think this is probably where currently in Germany we are best known in this sector, and model-based development and testing. This is, by the way, where we might establish also a very strong collaboration, because this is not as, we don't have that many people in that part of our competence setup. Here, process management, measurement, prediction, empiricism. Oh, sorry. I said before I have to pay. Process compliance. This is not only compliance to software development standards, but it's also sometimes to industry standards. So certain domains like in banking, like in health, so they have certain standards. You have to show compliance. On the information system side, compared to this, requirements engineering is a much more important term than in embedded systems, where very often the technical process defines part of the requirements. Here we have user experience, built up a competence center, an entire group. Architecture-centric engineering is the same here. Here it's a little bit more towards SOA. Security engineering, and I mentioned before that this is more data usage control oriented. Now, we built from every project, you might recognize some of these pictures from the time you were with us. In every project, we start with 5 to 10 hypotheses. We say we do not only want to solve a problem for a customer, we want to learn something. So for instance, if we use a new requirements technique, we say what is it we would like to learn? Is it more effective, more efficient, does it take more time, etc.? And so we do this without big involvement of the customer all the time. It's not a controlled experiment. You just try to extract some evidence, which then piece by piece gets assembled to have evidence about technologies, which for the next customer serves as a better basis for decision making. Yeah? And so I just listed here something like SAFE is a tool we developed to do reverse engineering, where you can see what the actual architecture is. Just to give you a hint, we just recently were asked by a customer who has a large system, which probably many of you have used, so I can't mention it, why after every release it's down for 1 or 2 days. Now, being an experienced doctor, when you hear symptoms, you kind of know what the cause is. So what we did is we applied our SAFE tool, did the reverse engineering. Then we compared the architecture they had on paper, not on paper, I mean, of course electronically, but they had, to the actual architecture, how the system after 5 years looked like. We found, at the detail level, 4,200 plus discrepancies. Now what that means is, this is like you have a house, you have a plan where the water and electric lines are, but it has been changed 100 times. Now you want to put in a nail for a picture. You take that description, but because it's not current, you're in and water comes out. Yeah? Now, this is, by the way, really what happens with these systems. If we have 4,000 plus discrepancies, nobody can maintain that system without creating new holes. Yeah? So what we then do based on, by the way, when you show this to top-level executives who are engineers, they do understand the problem. Yeah? Much better than if I say verbally, your architecture is not okay. I just show them this graphical abstraction, and they understand. And so here, we actually even went from analysis to construction. We have this now in the development suite, so the developers, when they change the system, get an alarm if they violate the architecture. So we did not only help them to resolve this, but also prevent it in the future from happening, at least if they want to. I don't want to go into too much detail. I just want to show you a few examples of projects we did. For instance, we have developed something that is, you don't have to read this, called GQM. How do you define or relate metrics to goals? Yeah, because what you should measure obviously depends on the goals you want to control for or you want to improve. We have now expanded this together actually with our center in United States. It's called GQM Strategies, which allows you to have goals across the hierarchy of an organization. So in some sense, you have a corset that says, this is the top level goal, this is refined into strategies at the next level and goals, and you also quantify it, so you can actually monitor the development of an entire organization. We have done this for several organizations. This is just one from a company, Murix, actually in France. By the way, this is what I said, we have a project in France. I said before, we don't have project. This is from a mid-sized company in the finance world, Cosmos. That's a financial service company, actually in Saarbrücken, not too far from here, which provides internet policies, so internet services. And so we helped them to actually set up their entire IT structure to support their business processes, their business goals. We work with companies, this is a company, a technical engineering company, where we actually introduced inspection reviews. And just to give it in a nutshell, I mean, what we did here basically is to allow them to find defects, like requirements defects. Normally, they are found at the beginning, requirements, but they slip through all the way to the end. So by means of these active inspections, I don't have time to go into this, something that really guarantees you to find a certain percentage of defects. They improved not only in terms of quality, but also cost and time, because if you find defects earlier, they're obviously easier to remove than if you find them late. And maybe just here a list of things. This is, for instance, a company that develops tools to measure engineering products. For them, we developed a product line approach. They built every measurement tool as individual product. And again, they went down from something like 3 months per customer product to less than a week. We work with Hitachi, Fujitsu. For them, we also do actually development of roadmaps. For John Deere, we actually work in two areas. We work in autonomous driving, because actually this is much more advanced than in cars. For a good reason, off-road you can apply it. I was just in Moline, was driving the newest harvesting machine, a huge thing. I was not really driving it, I was sitting on the driver's seat, watching the device mow a whole field. But the second part is moving from product to service. The CEO of John Deere has said in 5 to 7 years they will make 70 to 80% of their income by selling services as opposed to tractors or machines. Of course, they will sell the machines too. But as you probably know, in the product world, the price pressure is very intense. When you buy a box, you compare what's cheapest, what's best. Whereas if you get a problem solved, that's much more value. I mean, people pay much more. So most companies who come from the traditional product world try to move. Now, they don't just want to build apps. They want to build an app store with the John Deere user experience, also of high quality, because these apps are supporting people on tractors, people who are doing other activities on a farm, etc. So this has to be professional. With a company I cannot mention because that's just being presented at an exhibition, an automotive supply company, we developed control as a service. So you can download horsepower from the cloud to speed up your machine or your car, and also the insurance is computed for the time you are using that. Yeah? This is not a joke. There is a car running like this, and by the way, this is not even hard to certify because you're not really changing the machine, but you have a machine that has this capacity and you're basically freeing it. Daimler does this already today. They're selling the same engine block for different types of machines. Yeah, it's just done by software. Yeah? And so I think the trend will go more and more into these kinds of services, interconnected services. And of course, it's easier if you do it in a non-safety critical environment than if you do it in a safety critical environment. But here in this world of commercial vehicles, it's easier. So I don't want to dwell on this because this is very much what we do. By the way, this is our nice car. We have a real car for field tests, but we have models of this kind, about 10, that have really the behavior of a car, of the real car, where we can actually check software and so on, do model-based testing on that car to validate, verify and validate things before we actually do it in real cars. This is something I would like to talk a few minutes about. How do you collaborate with companies? You cannot do innovation for companies. You can only do it with companies. The large companies have no problem. They have typically large R&D units we work with together. And then it's their job to roll it out into business units. Small, mid-sized companies always have a problem with this. They don't have this capacity. So we were trying to work in different ways, and now our concept for several years is what we call joint R&D labs. That's nothing else than a normal project. It's not a legal entity, but people from the company work together with people from the institute on our premise. And their role is to develop some process or product innovation for that company. Yeah? Now, first of all, it's much faster. Because you probably all, if you worked with industry, you might have experienced this, that you go after 4 weeks just to find out that you again completely misunderstood each other. So you avoid that. The second thing is, of course, it's much easier to introduce innovations in companies because it's not ours giving them, it's our jointly developed, it's their innovation. Yeah? And thirdly, of course, for companies, we do it on a real project of their roadmap. So these guys are building together with my guys the next product generation for this company, and we are introducing new technologies, for instance, for architecture description or for certification on the job. So the company actually doesn't have to have additional resources, and they get benefits incrementally. This has been tremendously successful. We have now 5 of them. There's a limited number we can do based on space restrictions. Yeah? And what the companies do, they pay our guys, pay a certain overhead for the space, and then we discussed, should we do it at our place or in the company? And actually the companies insisted do it at your place. If we do it at our place, these people will never have time. Yeah? So the toughest part about negotiating such a collaboration is to get time of excellent people. And I mentioned before, if we don't get it, I have learned over many years, if someone tells me I don't have time or money, I know I haven't made it on their top 3 priority list. And then there is no point in fighting. Yeah? If it's important to them, they will give us the best people. And I don't want them 100% because I don't want to detach them from their business. I want them 1 day a week, 1 week a month. It depends on the topic. But these contingents have to be guaranteed. It's not possible, oh, something important happened, oh, this happened. Then we don't start this kind of collaboration. This, I believe, is the, from my point of view, most successful technology transfer model I have seen so far for small and mid-sized companies. Yeah? With big ones, you don't need that kind of overhead. It might work even there. We do some with John Deere because they are close, but it's not really important. This is a concept I would recommend to you to think about, independent of how you proceed. If you want to provide innovation benefits to small, mid-sized companies who don't have reserved resources for this. This has always been the problem all my life. This I don't want to dwell. We are represented. This is part of our reputation in most European and German large consortia projects that drive technology development, for instance, in the area of model-based development for embedded systems. We have this Spitzencluster here in the southwest between Saarbrücken, Kaiserslautern, Karlsruhe and Darmstadt, which is building together with SAP and Software AG and others the next generation of adaptive business process support systems. So adaptivity, security are key topics there. So this is part of us being part of the game, is we have to be involved in all of these projects. And over the years, we have come from driving it. Now we are being asked to be part of it, which is a nice change. The list of customers I don't want to list to you. But what I would like to do now is, this is Fraunhofer isolated. This was our institute isolated. How did we benefit from this in Kaiserslautern? And Kaiserslautern is a region, in terms of inhabitants, we are very international, probably not as international as Luxembourg, but international because we have 50 to 60,000 American citizens due to the American basis. So everybody speaks some English, so it's very easy to bring people in for shorter or longer period of time. And the center is, of course, the city of Kaiserslautern, of this area. So the founding part is the university. And this university has a few advantages. First of all, it's one of the youngest in Germany. And as you probably can imagine, in a younger university, you can change things faster than in very old traditional universities, at least if you want to. So we have very flat, we have no institutes. Every assistant professor has the same rights as every full professor. We have research groups. There is no hierarchy. If there is a hierarchy, it's based on experience, yeah, that you take someone on hand and help them into new projects, but not in terms of rights or duties. Like here, we don't have to fight for money in the state because we are the only technical university focusing on natural sciences and engineering sciences. And we have currently about close to 14,000 students. And another characteristic which is not listed here, we have about 4,000 distance students. So we already serve, in addition to students coming to us, the more professional community in terms of students. So one master student which I'm driving is called Software Engineering for Embedded Systems. And the attendees are very well respected engineers from Bosch, Daimler, Siemens. And what's the reason for them going to university back in the evening? Because many of them have to develop software today. When I started, out of 10 people in the development part, 9 were traditional engineers and 1 guy, poor guy, did software. Today it's almost the other way around. So you cannot throw out the engineers because they have the application experience. So you have to train them in software. And if engineers build software, that has some problems. Yeah? Because it's a different beast. I give you two examples. A development manager, mechanical engineer, told me, by the way, this is, don't misunderstand, this is not looking down at mechanical engineers. I'm just talking about the competence for building software with guaranteed quality. Everybody can program. Doesn't mean you can build software with guaranteed quality. Someone told me, how much more do I have to test to have a better PPM measure? Parts per million, which is a measure, for those of you who don't know, the quality of a production process. Yeah? And I said, stop. Would you go into production if you have a design defect? Of course not. And I said, all the software defects are design defects in your term. Why? Because if we copy it in 1 million cars, the defect is in every car. You would never go into production with that. If you realize that the quality problems don't come from the production side, materials or whatever, they come from logical defects. Yeah? The copying we can do well in our field in software. Then you have to apply different measures than just testing. Because with testing you can never guarantee that you have design defects out. Yeah? So this was one misunderstanding. Or I give another one, tolerances. Every engineer thinks in terms of tolerances. I don't have to explain to you that a digital product doesn't have tolerances. It's right or not. Yeah? With examples for a sign error, minus instead of plus, kill the pilot. Yeah? And these are different things. So almost right with tolerance is different terms. And engineers have to be prepared if they move from the engineering side to the software engineering side. And there are some changes. So that's the major part of this. And interesting thing is, I didn't invent this, but companies actually asked me to do this. In addition to the university, we have a large number of institutes. The most important ones are the two. Now we are actually creating a third Fraunhofer Institute. It's the German Center for Artificial Intelligence, and it is Max Planck Institute. We are the only location in Germany that has Max Planck and Fraunhofer in the same area. This Max Planck is on software systems. It's jointly with Saarbrücken. And this, again, is our philosophy. We say if you don't support the entire innovation chain, from basic research to applied research, that's Fraunhofer and tech transfer. And on the basic side, we also needed to have a critical mass. It was not sufficient to have 2 or 3 software engineering chairs. And the Max Planck Institute gives us now the critical mass on the basic research side on software systems. Normally, you probably know that basic and applied researchers, they are typically, when you look at Germany, as far from each other, the same topic as possible. Because we unfortunately have this discussion, what's more important, basic research or applied, one of the biggest nonsense discussions I have ever heard. Yeah? But that's the way it is. If you want to have impact, they are equally important. I fight very often for funding for basic research, because I'm on both sides. I have no advantage having a great Fraunhofer Institute and having a weak department on the other side. Yeah, I can't do more than taking the results from their side and try to make it ready for industry. Yeah? And on the other hand, the university has no impact, real impact, if they wouldn't have these institutes. So this is the situation, and this was only possible with the help of our state, which actually believed in this concept and invested a lot. I will show you in a second how this all started. And so here I have just put the map in Germany where we say basically this is excellent centers. We also have excellent industrial research called Spitzencluster in Germany, and we have excellent universities in teaching. So we have 3 kinds of labels that are given Germany-wide to the best. And what you see here is basically that Kaiserslautern is not positioned badly. The only ones that have all 3 are Freiburg and Munich. And then you have a list of those who have basic research and teaching. You have something that's basic and industrial research, but not in teaching. And you have Kaiserslautern. We are labeled excellent in industrial research, which is the Spitzencluster software, which I mentioned before, and in teaching. We're actually one of the 5 universities in Germany who have this label of excellent in teaching. So I think we are set up pretty well to create impact. I don't want to talk about the bridge function, but take this. So what our view is, we have the university, Max Planck, which from my point of view, as I said, is just creating the critical mass in the key area. We have these Fraunhofer Institute, I put DFKI, also it's set up slightly differently in the same region impact, and then we work with companies here. And currently we are trying to build a umbrella which is called Innovation Alliance, which is supposed to strategically align these even better. Now all this started when I came from the United States, and our governor Beck, who started at the same time, asked me to develop a model for technology-based job creation. And it was so simple. I mean, it's sometimes hard to present, but this is the basis for what we did. We said, today you can't attract companies by means of low rates for soil or for space or anything like that. You have to be able to give them prime access in innovation where their core competences are. And so when you want to do this, you have to cover the entire base. So for us, this was basic research. This is university, Polytechnic or Fachhochschule and Max Planck. Applied research, these are the Fraunhofer, now 3 plus German Center for Artificial Intelligence. ICT companies is kind of the ones who are the promoters and transfer agents for these results. Then research labs of large companies, that's what we can attract. And then they will create high-end production, not cheap production and services. So this we built up with the help of our state. And now here we created about 8,000 new jobs in a small city. You have to keep in mind the small city by means of spin-off and attracting some companies. And then with John Deere it started that the first large company said, because of this humus, so to speak, innovation humus, that's the place for us to do innovation for the future. Yeah? We have currently 3, 4 more we are talking to, and now they create high-end production. They create service jobs, yeah? Which now in the region, until 5 years ago, everybody said, oh, you are only creating academic jobs. And all the people who are released from the production companies, now we have reached that. This was always our goal, because then it's accepted in the region as really having made some conversion. By the way, we are not there, but we are on a good path. Now the areas we are mostly focusing on, because you can only build this up in a small number of areas. ICT, that's our core competence. Automotive in the commercial vehicle sector. We have all major commercial vehicle players in our state. And now health and energy. So those will be the 4 focus areas the entire university is aligning to. We have an agreement with our president that every new professor hired has to somehow describe his contribution to these focus areas. Now here is some, for each of the parts, some of the players, but that's probably not telling you a lot. And let me close with one statement. This is what we basically achieved with this model that was started some years ago, about 8,000 new jobs in 8 years. A tremendous benefit for a small region. And John Deere, Corning, Johnson Control, companies who have moved their R&D European center to Kaiserslautern. And when you read the press releases, you always hear 2 statements why they came. The first one in all of those is you really do interdisciplinary research. We don't look for the best computer science department. We don't look for the best mechanical. We look for math, computer science, electrical engineering, mechanical engineering. For these kinds of companies, these might be different sets for other kinds of companies. Yeah? And the second thing is you are supporting us from basic research to transformation. Yeah? And this is again the final statement about Fraunhofer. Fraunhofer is not just about applied research. We accompany companies to do the first prototype implementation, yeah? Or with transformation support. And this is what separates us from other organizations. And I'm far from saying one is more important. I think the real luck for Kaiserslautern was that we have players on each side. And I believe that I'm always willing to bet any sum you want, that you will not have sustained impact if you don't close that entire process. Now, there might be different ways of closing it, but I don't believe in people claiming to do applied research and the companies are just too foolish. I believe the Fraunhofer model is one that I would never introduce identically in Luxembourg. But I think, I'm convinced from all the people I know, there is a place for something Fraunhofer-like, to add more value to what you already have. This happens in the United States, we are currently negotiating in Finland and in Hungary. More and more countries recognize that this is a model that in some adapted way shows benefits. And that's what I'm here today. I'm not trying to sell you something. I'm trying to explain to you why this works. And you know the situation here much better than I. But maybe you identify some things that could be changed or could be added or could be modified to actually become more effective and more efficient. And if that is going to be the result, from my point of view, I'm happy. Thanks a lot.